In the last lesson, we saw how to make a basic database seeding abstraction that's suitable to our test app. But in the real world, we'll want something a little more robust. For instance, it would allow us to set defaults. Completed is false by default, so it doesn't make sense to have to specify that every single time. Next, ID numbers will be a little bit tedious to maintain. It would make more sense for these to be auto-generated for us. Finally, if we wanted to override an attribute, like we need completed to be true in one case, then we just need to specify that and our abstraction will respect it. One way to think about what we're aiming at is that we want our abstraction to provide some sensible defaults while still giving the end user complete control to override whatever they'd like. So let's make a new abstraction called a factory. A factory will define the defaults for each of our object types. We can make a manifest file. Under Cypress, we'll make a new folder called factories, and then a new file called factories.js. And this will be our manifest. So we'll say module.exports equals, and then create a hash. Our manifest file will simply require the related files that it needs. So we know that we'll define to-dos under todos.js. And this is where we'll define our defaults. So we'll say module.exports. We'll say the default text is hello world, and the default completed status is false. And we want our seeding abstraction to support these factory defaults. So let's open up Cypress, support, commands, and we'll create a new Cypress command to do this. So let's go ahead and scroll to the top of our file and require our manifest file as const factories equals require, and then require our manifest. So let's add our new Cypress command. It's called seed, and it accepts a hash of seeds, as well as some options so we can configure it not to log if we don't want it to. In order to apply our defaults, which we'll call mapped seeds, we'll need to reduce our seeds, and the reducer function will have an output. That's the seeds with the defaults applied. It will have an array of seeds that we're currently applying defaults to, and it will have a current key, which is the name of the model, aka to-dos in this case. And then we need to pass in a hash that will serve as our output to the function, which will hold the seeds with defaults applied. So now let's start writing the reducer function. First, we find the factory for the current model. So we'll use our manifest file to look up the correct factory. In this case, it's the to-dos factory. Otherwise, we can explicitly label that the factory is undefined. Now, if the factory is undefined, we'll go ahead and specify that the seeds with defaults applied is just the user-specified seeds, because we haven't defined any factory defaults yet. If we have defined the factory, we'll go ahead and map the seeds, and we'll use lodash.defaults to apply the factory defaults. So if options.log is not false, then we'll log out to Cypress. The name of the log is seed. Message is the seeds with defaults applied. Console props, same thing. Finally, we'll actually call our cy task that we defined in the last episode. So we pass it the seeds with defaults applied, and we make sure it doesn't log because we already created our own logging functionality here. Great. So let's go ahead and use our new command in our test. We can pop back to our test file, change to cy.seed, no longer need to call the task, and let's delete everything that's not default. Obviously, we haven't set primary keys yet, so we still have to add a primary key, but let's do this and reopen Cypress. And we'll see that we have the text hello world, which was our default. We don't have completed set, so that's great. We can override completed and see that that should override it for us. And we see that it does. Awesome. So the one thing we have left to do is figure out primary keys. So let's look into that. So let's pop open our console, and we'll create a generator function. So a generator function is a function that can stop midway through and then continue where it left off. So we can use a generator to generate a series of numbers that continues increasing. So first, we'll define the ID variable, and this is the variable that we're going to increment. Next, we'll define a loop that never exits. So whenever we call our generator, it'll always yield the next number in the series. So we'll say while true. Then this is where we pause the function. We'll say yield when we're yielding the next number in the series, and then we pause, and next time when we run the function, we unpause and yield the next value, then repause and repeat over and over. So finally, we'll just check if the value has gotten too large, at which point we'll just reset it back to 0. So it'll go up to whatever this is, 10,000, 100,000, and then it'll go back to 0 and start over again. So we can just test this out and show that it works. So let's hop back into our commands and create a hash of generators. And we'll look through each of the keys of the factories and just create a new one for each. So let's paste in our generator function. And we'll say _.each. So for each of the factories, we'll get the factory and the key. And we'll say generators key equals, and then we'll just make a new generator function. And so then we'll come down here to the location where we'll actually use this function. And we'll keep applying the defaults in order. So we'll just add an ID, and we'll say that that is the generator for this particular key. And we'll call .next .value. And that'll give us that value. So then we hop back into our test, and we can just delete any of these defaults now. And we can create a second to do. And we'll just say that it has the text hello world 2. And we can copy out this assertion. And we'll just change its primary key and its text to hello world 2. And again, it's getting this primary key 2 and 1 just based on the order these are created in. And we'll say that the length of the to-do list will now be 2. And go ahead and update this to be hello world for our default. And let's run our test. And we'll see that it passes. So we just have a few more hiccups that we want to think about. For instance, if we run 2 versions of this test back to back, but let's say we comment out our cy.seed at the start of the second test, which means that we shouldn't have any to-dos. We should have an empty database in the second test. We go and see actually that the second test passed, and we do have all of our to-dos loaded in, and that's because we haven't reset the database in between every test. So if we want to reset the database, what I like to do is go into our commands, and we'll say before each, and then in the before each, we'll call cy.seed, and then we'll pass it our reset state. So we can take a look at that. And now we'll see that the second time we did actually seed an empty to-dos array. And we do that actually the first time as well. We seed the empty to-dos array, but then in the test, we run our own seeds, and that's what actually gets us the data that we want. So that resets us to a totally blank state, which is great. But the next thing to think about is that if we do call 2 versions of this test back to back, the second one will fail. And the reason for that is because we actually keep the generator function running. So instead of this being ID number 1, it ends up being ID number 3. And we don't want that because we want each of these tests to be totally isolated from each other. It shouldn't matter whether both of these tests run one after another. We want them to be independent, right? So what we have to do for that is to reset our generator. So let's go back up here, and we can create a function called reset generators. And in here, just go ahead and paste this reset. And then in our before each, we'll just make sure that we also call reset generators. So now we'll reset those generators between each test. And now we have true isolation and a much more robust and production-ready database seeding tool.